To position and animate the camera in a 3D scene, we have discovered few ways to do it. By manually setting the position and rotation of the camera, but also by using different kind of controls, like orbit controls. But sometimes to create some animations or transition, we need more controls over the camera, and it would require a lot of code and calculation with those tools. Fortunately, there is one library that can help us with that. It's named Camera Controls. That's a library that allows us to perform some camera movements or animations very easily. By chance, Dry Library has even a wrapper around Camera Controls, which makes it even easier to use. The starter pack contains the 3D model of an iPhone 15 Pro Max. I found it on Sketchfab. If you use it, don't forget to add the credits to the original author. And the starter project contains also the UI that we will use to build our camera transition. Here is the final project of what we are going to do. For now, if we start the starter project, we can only see the iPhone 3D model. We can rotate around, but it's with orbit controls. So let's replace it with camera controls. Because it's already in Dry, we don't have a lot to do. We can just get rid of orbit control, remove the import, but me, when I save it, does it automatically, and add camera controls. Let's also add a reference to it. We will name it controls. We'll use it to do some operations on the camera controls later. So const controls is equal to useref, and we import it. If we look at what we have now, we don't have a lot of difference. We can still rotate around, pan, zoom in or zoom out. So it's like orbit controls, but there are some actions we can do we couldn't do with orbit controls. You can check in the documentation, a lot of properties we were using on the orbit controls are also available on camera controls. I recommend you to check the documentation to see the list of the different ones available. You will find the link in the text content of this lesson. The part that will interest us is the method sections. It's a lot of methods that allow us to do some camera movements and transition. Let's discover some of them. To try some of the method, because we already have the reference to it, we will be using use controls from Leva. We will create a group for each method. The first one we will discover is dolly. We will create button action. So one will be in. It will be a button from Leva. And what it will call is controls.current. The name of the method, so dolly. And we'll call it with the 1. And true is to say if we want to animate the result of it or if we want to perform it directly. So we want an animation, a smooth transition, we set it to true. Then we create a second one, dolly out, and it's -1. Now what do we have? We have those two buttons on the top right. We can click on in, it will zoom in the camera or zoom out the camera. But if we move our camera elsewhere, if we call dolly in, it will zoom in front of it and zoom out in front of it. So it's very practical. If you want to do it without camera controls and with orbit controls, you would have to make a lot of calculation to know where to be and where to zoom in and zoom out. We used one for the distance, but you can use different parameters, 0.2, -3. Now, if we zoom in, it's just a little bit. And if we zoom out, it's zooming far away. Let's set it back to 1 and let's discover another method. The second type we will discover is named truck. So what it allows us is to move the camera following a direction. So up, down, left, and right. Let's add the different controls for it. The first parameter is on the horizontal axis. So for up, we set it to 0 and we set it to -0.05 for the vertical axis. We repeat the process for each direction. Now we still have our dolly in and out, and now we can go up, left, down, and right. It gives us a nice cinematic effect. Of course, we've chosen one direction at a time, but we could add another one, like diagonal, and track it slightly down while going to the right. If we try it diagonal, you can see it's going slightly down and to the right. The next method we will talk about is rotation. The camera controls is using orbit rotation to look at an object. It's the same kind of movement we do when we are using our mouse. We are moving in orbit around the target. Like we did for dolly and truck, let's use control for the rotate group. We'll add a up, down, left, and right directions. Now let's try the controls. When we press rotate up, it's our camera that is going up, and it's not where we look that is going up. So it's useful to look at a focus point. That way we are always looking at the right direction, but we can rotate around. So far we have been using the enable transition set to true. So when we press on a button, we have that nice transition, but we have no control yet about that speed. On top of our code, let's add another use controls. We name it settings, and we will add the smooth time with a value of 0.35. A minimum of 0.1, a maximum of 2, but of course you can try different values, and a step of 0.1. Then on change of the value, what we will do is we will call controls.current.smoothTime will be equal to the new value. Now let's have a look at what we have. When we do left and right, we have a transition that is at that speed. If we set it to the minimum, left and right is very fast, while if we set it to a long time, the transition will be very slow. Let's discover another set of methods provided by camera controls that allows us to position the camera to see a whole scene. The methods we will discover are fit to sphere and fit to box. So we will need to define two meshes, one for a box and one for a sphere. We create a mesh and we will assign it a reference named box. We added the geometry and its material in a wireframe mode. We do the same for a sphere, so a reference named sphere, its geometry, and a basic material with a wireframe mode too. Now let's create the references to it. So we have box and we have sphere. So those box and sphere are just visual helper to help us positionate the camera when we will call those methods. We create a new group with use controls. We name it fit. And inside we have two methods. Fit to box. What we do is we call the method name fit to box and we use the reference and the transition. And fit to sphere, we call fit to sphere with the reference to the sphere and we set the transition to false. Let's try the different one. So if we use fit to box, we have a nice transition and we can see our whole mesh is always visible. So if we go way far away, fit to box, whatever our resolution of screen is, we will be able to see always the whole box. So if we rotate the camera, we can always see it. So it's useful if we want to see the iPhone model every time on every resolution. If we want to try fit to sphere, I set no transition, so it's directly applied. And now we can rotate around that sphere and we always see the entire sphere. So maybe the sphere is a bit too small, so we can't see the entire iPhone. But if we set it correctly, we will be able to see it without having to do any complex calculations. So based on your 3D scene, you will choose to use a sphere as a reference to do the calculation or the box. It's up to your project and what you want to display. Now we have seen most of the essential camera controls method. Let's see how we can create our transitions for our 3D slider. First, let's get rid of leva. So we'll add leva here and the hidden props. We also add our UI component that is in the starter pack. We need to import it, but it requires a section and an on section change callback. So set section. We need a state to store our current section we are displaying. Use state of 0 for the first index. Let's also hide the box and the sphere we just created. So in experience, we add visible to false for each of them. Okay, what do we have if I reload? We have that nice fade-in effect. We can click on the arrows or on the dots, and we have the different texts that are changing. What we need to do is based on the section to perform a transition to display the right part of the iPhone. Let's start by creating the intro animation. We'll create a method for it, named intro. It has to be an async function. I will explain it to you just after. And we'll call our method from a use effect when the component is mounted. So we'll call intro. So the first thing we want to do is to positionate our camera at the right position. Either you can use the default camera settings here, but if we want to change it, we don't want to go here every time. So we'll just call controls.current.setLookAt. And the first three parameters are the camera position, so 0, 0, and 5. So our camera is far away. And where we are looking at. So on the X position, Y position, and Z position. We all define them to 0. and then if we want a transition or not, but we don't want it. We want it to be the starting point, so we don't want to see an animation to that point. Then what we want to do is to call controls.current.dolly to zoom out our camera. So we'll call it with 3 and true because we want a transition. Then we will want to rotate our camera. Controls.current.rotate, and we'll use deg to rad of 45 degrees horizontally and deg to rad 25 vertically. And we also want the transition. But currently we are calling both at the same time, and we want to call them one after another. And because we are an async function and all the method that we are calling return promises, we can await it. So it will wait the dolly to be finished before calling the rotate. We can also await it. If we reload, we have the dolly effect, then it performs the rotation and the text is appearing. Now what we will want to do is to perform a transition every time we change the section. To make it easily, we will create an object containing all our camera positions. We create our object, and for each key, intro, titanium, camera, and action button. Then we will need our experience to know what section it is currently displaying. So section, and in our app, bind the section here. So our camera positions object, they contain the position of the camera and the look at. So it's the same method we used for the intro, which was here, set look at, the camera position, and where we are looking to. Now let's create a new method, name it play transition. We will call controls.current.setLookAt. We will destructurate camera positions of the current section, and we want the animation. So we set it to true. But camera position is the name of the sections. So what we will need to do is to call sections of section. And we need to import the sections. So it's import sections, and they are defined in the UI. So it's UI. Let's have a look at them. It's just an array. So for 0 it's intro, for 1 it's titanium, etc. Now we need to create another use effect that will be triggered when the section change. So in the list of dependencies, we add section. And we call play transition. But for the first section, we'll have an issue because we will call intro, and we will also call use effect of play transition for the first one. So we will need to do a workaround. Let's create a state named intro finished and set intro finished. It will be equal to use state of false. So by default, it's not finished. When the intro will be finished, so it's after our rotate method, we'll call set intro finished to true, and we will manually call play transition. So for the first one after the intro. And here in our use effect based on the section number, we check if intro is finished. So if it's not finished, we will return. So it won't call play transition for the intro. Let's have a look at what we have right now. So we are zooming in, doing our intro animation, and it's going to the first position. But for now, all our positions are 0, 0, 3, so it's not very interesting. We could try to positionate all of them manually, but it would be a bit painful. Instead, we'll be using Leva again. So in our app, let's remove the hidden property, go back to experience, and we'll create a new group, maybe below the other ones. We'll name it helper. Inside, we'll create a button named getLookAt. So we'll get the position of the controls, we'll get the target where it's looking at, and then we'll log the position and the target. So we will just have to copy those values inside our camera positions. So now what you have to do is to positionate the camera the way you like it. Let's say I want it to be this way. I will pan it a bit on the side. You rotate it, find the right lighting, right position. When you are happy with it, you call getLookAt. It will log in the console the properties you want. You copy it, then you repeat the process for each section. So now after the introduction, we appear here. If we change, we have a new position showing the titanium body, then the professional camera, and the action button on the side. If we go back to the first slide, we have the titanium and we can see the iPhone. It's looking good on desktop, but what if we look in mobile what we have? So let's reduce the size. You can see it's not optimal. We can see everything and it's a bit cropped. One easy solution if you want to see everything is to call the fit to box or fit to sphere method. While I think it's a good method to use for our use case, I think it's better that we just define the position we want when we are on smaller screens. So let's create a new object containing our camera position but for a small screen, and we do exactly the same process. Now you have your camera positions for a small screen. We can define a threshold where we want to trigger that we are using the small screen position and rotation instead of the desktop ones. So let's name it small screen threshold. I will be using 900, but you can use whatever you think is the best. When it's starting to look bad on smaller screen, you want to switch to the small screen positions. Now, very easily, we go to our method playing the transition, and we'll add a condition. If our window.innerWidth, the size of the screen in pixel, is below the threshold, then we will play the small screen. Otherwise, we'll play the desktop ones. So we copy it and it's camera position, small screen. Let's also get rid of leva. So add hidden. Now on mobile, we have that nice effect. And the position is very different to what we had on desktop. Because we can put it on the side without it to be truncated, I decided to put it slightly rotated upward and to be behind the text. Now if we switch, we have a different effect, but that is looking good with the space that is available. Action button, it's perfectly aligned. And we are going back to the intro section. Because what we wanted to achieve was quite simple, we used getLookAt to get the position and target of the camera. But instead, if you want to go further, you can get all the information of the camera. So you can use toJSON, we'll create a helper for it. And we will console log controls.current.toJSON. Now if we call toJSON, we have all the different information of the camera. Maximum distance, the dragging smooth time, so you can be very precise and add different effects, not only the position of the camera and the look at position. And once you have your JSON of the camera from toJSON, you will have to call the from JSON with the string of the JSON you got. To finish our project, we don't want to let the user still rotate and move the camera. With camera control, you can define for each button, so mouse button left, right, or the wheel, what action it will perform. So either it will rotate, shrug, offset, dolly, but we will define all of them to known. So it's working for the mouse buttons, but also for the touches action, so on mobile devices and tablets. What we want to do is to disable all mouse buttons, so we set all of them to 0 is equal to actions known, and same for the touches events. Now we have our transitions working correctly, but the users, they can't move the camera. Only us have the full control, providing a great experience to our users. Camera Controls is the fantastic library to create camera animations and transitions. As always, I recommend you to dive into the documentation to see all the different methods we didn't see together.